In today's lesson, you're going to learn a different law of exponents called the quotient with same base rule. 3 to the power of 7 divided by 3 to the 5th power. So if I were to write these out, and again, I'm only going to write this out to show you what it would actually look like. I would write out 3 multiplied by itself 7 times, divided by 3 multiplied by itself 5 times. And so because I'm dividing your numerator with your denominator, then I would go ahead and start crossing these out, because 3 divided by 3 gives me a 1. And I will cross them out until I don't have any more to cross out. And then what you'll see is that you have 2 3's. 3 times 3 is actually 3 squared. But what I want us to look at in this exercise is at what rules and generalizations can we come up with based on what we have done in this problem. Again, our exponents give us a lot of information. And so if I were to just write the same base here and look at my exponents, I notice that 7 minus 5 give me the exact same answer as 3 squared. So our first rule is that if you have the same base, of course all of these work only if you have the same base, and you're dividing, you can go ahead and subtract your exponents. So let's give that a try with our next example here with a to the power of 8 divided by a6. And we know that a to the power of 8, and I'm going to subtract this other exponent here. Our final answer would be a squared. So in this next example where we have x raised to the power of m divided by x to the power of n, I can also apply the same rule. And I can do that because I have the same base. So in here, because I'm dividing, it'll be x to the power of m minus n. And this is as far as I can go because I don't really know what m or n stand for. Now, why don't you go ahead and try to do this next problem. A divided by b to the power of 3 divided by a or b to the power of 2. What would that be? Go ahead and pause the video and give it a try. Welcome back. We notice that we have the same base in both of these problems, and our base is a over b. That's a fraction. And so what we notice is that we also have these raised to the power of 3 and the power of 2, so we can go ahead and subtract it, and we are left with a over b. Now, we don't have to write the power of 1, but if you wrote a 1, that's okay as well. Let's go ahead and try to tackle these with the law of exponents that we just learned. If we look at this first example, we have 9 divided by 3, and even though 9 and 3 are two completely different bases, I also know that 3 is a factor of 9, and so I can divide 9 by 3. That'll actually give me a 3. So I'm able to simplify these numbers even though I don't have the same base. Now let's go ahead and tackle our variables. We have c and we have d, and my first exponent here is a 5. The second exponent here is a 2. My first exponent here is a 3, and my second exponent here is a 2. And notice that I'm putting my exponents that are in the numerator always first. That's very, very important. So if I were to simplify this even further, my final answer would be 3 times c to the 3rd power times d to the 1st power. I know that even though I don't see a denominator here, I know that there's a 1 as a denominator. So I'm going to go ahead and pull out my coefficients to try to see what I can do with them. I have a negative 6 and a 5 being multiplied together and divided that by a 3. Now I know I can multiply negative 6 times 5 and get a negative 30 and then divide that by 3. But I also know that I can divide a negative 6 times 3 and get a negative 2. And then when I do that, I'm going to get a final answer here of negative 10. Because negative 2 times 5 is negative 10. Now let's go ahead and move on and tackle our variables. X's, we have a 5, and then we have a 4. If I were to subtract that, my final answer would be negative 10, x to the power of 1.